about roots and radicals. So this is a radical. And what we have to pay attention to is to simplify the radical, we need to know the number right here, which is the index. So without a number written there, it's a 2, which is where we get the square root. If it was a 3, it would be a cube root, etc. And the number underneath the radical is called the radicand if you see it in the book. All right, so radical sign is determined by what's on the paper. So for example here, this is asking for the square root of 64. And just like if I asked about the number 5, with nothing in front of it, we know that the 5 is positive. With nothing in front of it, we know the square root of 64 is positive, so that would be a positive 8. If they put the negative in front of it and ask us to evaluate it, then it would be negative 8. If it says both plus and minus in front of it, then it's both positive and negative 8. Okay? So don't confuse this when we put in our own plus or minus. That's when we're solving an equation, not when we're just simplifying or calculating or evaluating an expression. So the cube root of negative 27 means what number to the third power would equal negative 27? So that would have to be a negative number, and specifically a negative 3. Here, the fourth root of 16 means what number to the fourth power equals 16? That's 2, and because the negative in front, we would say our result was negative 2. And right here, as of right now, we'll say there's no solution for our fourth root of a negative value. Okay. All right, so if we want to take the sixth root of x to the sixth, the answer is x. But there is a little bit of a caveat here. So something we have to pay attention to, because the problem is we don't know if x itself was negative or positive. So think about if x is negative 3, I'm saying that the sixth root of negative 3 to the sixth power is negative 3 if I plug in x with my solution as it is right there. That would never happen, because if we're taking the sixth root of something, first of all, what's in there would have to be positive, and then because there's no negative sign out in front over here, we would have to end up with a positive. So this does not make sense. So in order to guarantee the person that I understand the answer is 3, but I would have to make it positive, I would need to place absolute value bars around my x. Okay? So again, this situation is only going to happen when the index is even and you're using variables. In order for you to show the person that you understand, it will be the number value of x, but it would for sure be positive. Okay? Same idea here with two different factors underneath the radical. The fourth root of 16 is just 2. Okay? The fourth root of x plus 3 to the 12th. Okay? So the fourth root of something to the 12th would be that same something to the third power. And that something in this case is x plus 3. X plus 3 to the third power is not for sure going to be positive, but we know our answer in this problem is supposed to be positive, again, because it's a fourth root. So what I'd have to do here is I'd have to place absolute value bars around this one. I don't care if your absolute value bars included the cube. The book will write it like this, but it doesn't really matter. So our final answer would look like this. So last portion, again, we're taking the sixth root, so this better be positive. And when we take the radical, it should be a positive answer because it's an even index and there's nothing out in front to make it negative. So because this is to the sixth and so is this, we're just going to get x times y squared. The y squared is for sure already positive because it's some number that's being squared. So I don't have to worry about making that positive. But the x is not for sure positive because it just says x. So if it had been a negative 3 or a negative 8 or something negative, it would show up negative here, which doesn't make any sense. So again, that has to be enclosed in absolute value bars. So again, I'm using the absolute value bars in my answer around an expression that has a variable to show somebody that it should be positive no matter what the number value is. This is only significant in even indexed radicals. Okay, so I'm simplifying under real numbers. That takes away the imaginary part. So in A, has has a plus or minus in front, so I'm looking for both positive and negative answers. The square root of 49 is 7, and the square root of x to the 8th would be x to the 4th. No absolute value bars are needed here for several reasons. First, the x is already raised to the 4th power in my answer, which means there's no way it would produce a negative on accident. Secondly, because the problem wanted both positive and negative, I don't really have to worry about whether it's supposed to be negative or it's supposed to be positive. Okay? In part B, I'm going to put a negative sign in front of my answer because it has one in front of the radical. I'm taking the square root of something to the 4th power. So the square root of something to the 4th power is going to be that same something to the 2nd power. And that something was a squared plus 1. Again, I don't need absolute value bars for a couple of reasons. First of all, it has nothing to do with the negative. We would still need absolute value bars if we wanted it to turn out to be negative, because we would need to make sure this part was positive so that the negative actually made the answer negative. Here, though, I don't have to put absolute value bars around this to make it positive, because there's two things. First of all, a is squared, and it's always positive, and it's being added with 1, so the value in here will always be positive. Secondly, that's being squared, and that again would make it positive. So I don't need to include absolute value bars because there's no confusion about this expression no matter what you plugged in for A. This answer, this portion of it would be positive, and then the negative in front of it would turn the answer negative just like you wanted for your results in the problem. For part C, I'm taking the 5th root. So I don't even need to worry about absolute value bars because odd indexed radicals can have both positive and negative results. So the 5th root of 32 is 2. Break it down if you're not sure how we got that. The 5th root of x to the 10th would be x squared. And the 5th root of y to the 15th would be y cubed. So that would be my answer. So the odd indexed radicals will be a little more straightforward because we don't have to worry about the absolute value bars. And then in part D, since we're only looking for real number solutions, we would say no solution for the square root of negative 16. Okay, these are answers for the you try problem, so try them. Write notes and questions below them on the ones that you didn't understand and bring those to class with you tomorrow. Same idea here, so the 8th root of something to the 8th power is just whatever was being raised to the power. But again, in this case, you would need absolute value bars because this is supposed to be positive. You don't know anything about A and N, so you can just put absolute value bars around that. Same thing with part B. It's a 6th root, which means the answer needs to be positive. This will for sure be positive because of this, but this is not guaranteed, so I need to put absolute value bars around the x. For part C, I get this. Because this is cubed, this will not guarantee to be positive. Even though y squared will make the y positive, 3 minus that number might not be positive. So I'm going to go ahead and put absolute value bars around that as well. All right, so again, here's a couple of try these. And note for this first one, you can't take the square root of something unless you have perfect squares. So it will help you to factor these. And then finish taking whatever indexed radical you're trying to take. So in the second one, the square root of 36 is 6. The square root of g to the 6 is g to the 3rd. It needs to be positive, so absolute value bars around g. So that's basically what this lesson is about, just simplifying radicals. So make sure that you go through, try it. If you want to start homework, you can look at the assignment sheet and start homework 1, but you don't have to.